So I'm Monica Sarbu, and I'm a proud software engineer and working at Elastic. Currently, I'm leading a team that is responsible for Bit and Logstash. Elastic is a company behind Elastic's open source projects like Elasticsearch, Kibana, Logstash, and Bit. And today I'm going to talk about how to monitor Kubernetes using the Elastic Stack. But first, let's see what the Elastic Stack is. So Elastic Stack consists of these open source tools like Bits, Elasticsearch, Kibana, and Logstash. Bits are lightweight shippers. They are written in Go, and if you install them as an agent on your server, they collect all kinds of operational data and they insert them to Elasticsearch. And then you can use Kibana on top of Elasticsearch to visualize the data. You can also put a Logstash in the picture if you want to enhance your data that you collected with data from external databases, for example. So Bits we use a plural because it consists of a series of products. We have a bit for each to solve a particular use case. We started with Pekibit to collect network data. Then we have FileBit to collect the logs from your servers. And then we have MetricBit that collects the metrics. And the way it does it, it interrogates periodically external services, fetches metrics from them, and then inserts them to Elasticsearch. For Windows lovers, we have WinLogBit that collects the Windows events logs. We have Heartbeat for uptime monitoring, and the way it works is that it sends periodically pings to servers to see if they're up or down. And also can generate HTTP requests to services to see if a service is up and running. And the newest addition to the Bits family is AuditBit, which is an alternative for ODD, but is built and is better integrated with the Elastic Stack. And this one is for security use cases. All of them are built on the Bits platform, as we call it, libit. So in the last 3 years, Bits experienced a steep growth. There were more than 50 million downloads, cumulative downloads. And in the last year in Bits, we introduced a lot of features to make it easier to monitor Kubernetes with them, with Bits. So I would like to use this presentation to tell you about what features we introduced in Bits to make it easier to monitor Kubernetes. Before that, I would like to take a moment and go through all the challenges that a monitoring system has when it has to monitor Kubernetes. And the first one, and the most important one, is that in Kubernetes, everything is a moving target. So, because it's easier to create and delete pods whenever you need it. So it doesn't make sense for the monitoring solution to have a static configuration. So the configuration needs to be dynamic, needs to be able to adjust the configuration every time something happens in your infrastructure. If a container is started or deleted. Because it's such a dynamic infrastructure, it makes sense to offer a high-level overview of your infrastructure, so you can easily detect when something is wrong in your infrastructure, and then you can also have it will be nice to also have the possibility to drill down and see more details about where the problem was caused. Another problem is scalability. So in Kubernetes, it's common to run thousands of services. And when you scale it, the number of services grow. So you need to have a monitoring solution that is also able to scale as well, together with your infrastructure. So if you want to convince developers to deploy their application into your Kubernetes infrastructure. You need to provide them with a set of tools to make it easier for them to monitor the applications. And probably you need to collect as much data as possible about that application. So you will end up collecting logs, metrics, as well as traces. Now let's see how you can monitor Kubernetes infrastructure with Beats. And let me also tell you how we solved these challenges in the Beats. So first you want to monitor Kubernetes itself. And for that you need to, you can use the Kubernetes module in MetricBit, and you can get node metrics from Kubelet, you can get state metrics from kubestate state metrics, Kubernetes events, and other metrics from Kubernetes API server. I won't go into details here, right? But this is not enough, right? You need to also monitor the applications and the services that are running inside Kubernetes. So you want to get the logs, the metrics, and the traces from your application and services, and then push them into Elasticsearch. And the biggest advantage of having all these three into the same central point is that you are able to correlate data. For example, you'll be able to see for a pod or for a particular container or for a particular namespace, you can see an overview of your service, you can see the logs that are coming from that service, or you can also see the traces. So first, let's start with how you can collect the logs from your service. So we have this Docker input in FileBit that understands the format of the logs that are written by Docker if you are using the JSON driver. And what it does is that it tries to get the logs of the container from the default path, and then also it's trying to parse a bit the log message and extract the timestamp. So this timestamp that you extracted from the logs is basically the time when the log was created. So you can push it, or you can have in Elasticsearch this time when the log was created and not the time when the log was read by FileBit, which is very important, right? To have the right time. In such a dynamic infrastructure, it's important to know from where these logs are coming from. And for that, we can make use of the metadata. And in Beats, we have a series of metadata processors. We have add cloud metadata that basically enriches all the events that are collected with Beats with cloud metadata, like availability zone, a region, and provider, and so on. Add Docker metadata that enriches all the data that are coming from Beats, logs, metrics, and traces, enriches them with Docker metadata, like the Docker ID, the labels, and the name of the container, and so on. And also add Kubernetes metadata that enriches the events that are coming from Beats with Kubernetes metadata, like the pod, the name of the pod, the namespace, the labels, annotations, and so on. So you can enable one or multiple ones at a time. And here is an example where you enable add cloud metadata and add Kubernetes metadata. So as you can see here in this event that is generated by the Beat, you will have the section on top. You have the Kubernetes section where you have the name of the pod, the name of the container, the namespace, and the labels. And also for the cloud metadata, you have the name of the provider. In this case, is Google Cloud, and then the instance name and availability zone, and so on. After you collect the logs, you also have to understand the logs. You need to parse the logs. And for that, we have introduced FileBit modules that basically are prepackaged configuration that contains configuration file for FileBit, but also pipeline configuration that you can use to parse the logs in ingest, not in Elasticsearch. They also contain dashboards that you can use to visualize the data that you collect, and also ML configurations. So basically, they contain everything you need to have an out-of-the-box experience for collecting the logs from a particular service. And we have support we added FileBit modules for the most common services out there, like Apache, Nginx, Kafka, PostgreSQL, Redis, and so on. Similar, we can collect the metrics from services. So with that, you can use metric-bit modules that are similar with FileBit modules, but the difference is that the modules are interrogating external services and fetching metrics from them. And then they also contain dashboards, ML configuration, and so on. So we have metric-bit modules for the most common services. For example, web servers, Apache, Nginx, queues like Kafka, Redis, RabbitMQ, data stores like MySQL, MongoDB, Graphite, and so on. Custom application like JMX, Jolokia, Memcached, HRProxy, Zookeeper, and so on. The third data type are traces. So basically, this is when you instrument your application. And this is done by Elastic APM in Elastic, and previously it was called Opit. Was a company that was acquired by Elastic last year. And they created this APM server that basically collects traces from all the agents. It's based on the Bits platform, so that we call it libit. So it comes with benefits from this metadata that we collect. So basically, you could add Kubernetes metadata to enrich your traces with the pod name, with all the Kubernetes metadata. So you can identify from which container or from which namespace this trace is coming from. They have a few agents, Python, Node.js, Ruby, RAM, Java, which has an alpha version, and we are working on a Go version. And the most important for most of you is that it's Apache 2 license. So if you are instrumenting your application in Prometheus, then you can also use the Prometheus module in MetricBit to pull the metrics from your application and then push them to Elasticsearch. Now let's talk a bit about how to deploy FileBit and MetricBit in order to monitor your Kubernetes. And so you can use you can deploy MetricBit and FileBit as daemon sets that make sure you have a single FileBit and a single MetricBit run on each node. From my point of view, this is a scalable solution because it pulls locally the data that monitors all the pods that are running on that node. So when you want to add more nodes, then you will basically need to install another daemon set with FileBit and MetricBit. And then that's it, right? We provide manifest files, sample manifest files to deploy FileBit and MetricBit as daemon sets. And here is an example of a FileBit manifest file that you can download and then change it to for example, you can change the Elasticsearch URL and things like this. And then you can use the kubectl create command with the manifest file to create a FileBit daemon set. Like I said previously, all these manifest files that I show you, they contain the bit configuration. In the previous case, FileBit configuration. So, and I mentioned earlier in my presentation that, that it makes sense to have the bit have a dynamic configuration. So let's see how we solve this in bits. So we have introduced this Autodiscover feature, and the way it works is that it watches for Kubernetes events, and when a new container is started, in this case, in this example, that has a Kubernetes namespace kube system, then it enables the Docker input in FileBit to fetch all the logs from that specific container. And as you can see here, the configuration file is passed as a template. So you can see that this placeholder here basically is this placeholder here basically is overridden with the container ID. Besides having the configuration file besides having the configuration template in the configuration file of the bit, you can also have the configuration template in the annotations of the pod or in the Docker labels. So basically, you can specify in Kubernetes a series of annotations, and then you just have to do is to enable these hints here, and then it will search for coelastic.logs. And when it finds it, then it enables the nginx module in FileBit in order to fetch, in this case, access and error logs. Similar with metrics, it searches for coelastic.metrics, and every time it finds it, then it enables the nginx module in metricbit. And here I have a small demo about how to use Autodiscover feature in bits.
Hi everyone! Starting with 6.0 release, Elastic Bits have native support for monitoring Kubernetes and applications running inside Kubernetes. This is one of the most comprehensive monitoring solutions for Kubernetes, as we handle logs, metrics, and APM data, all enhanced with Kubernetes metadata and perfectly integrated with Kubernetes. In our documentation, we provide sample manifest files that you can use to deploy FileBit and metricbit as daemon sets, which means that you will have a FileBit and a metricbit instance on each node in Kubernetes. Let's now deploy FileBit daemon set by using the kubectl create command. A critical feature for any monitoring solution for Kubernetes is to be able to dynamically adjust their configuration when something happens in your cluster, because you don't want to change the configuration of the monitoring solution each time a new pod or application is deployed in Kubernetes. In this is solved by Autodiscovery feature that allows you to automatically start new modules when new Kubernetes pods are created. And here is an example of the FileBit manifest file. This contains an example of the Autodiscover configuration. In this case, FileBit subscribes to Docker events and looks for new pods with nginx image. And if such pod is starting on a given node, then FileBit initiates a module for collecting and parsing the nginx logs. As you can see here, the module configuration is a template in which you can use the Kubernetes metadata. Now let's scale the nginx deployment to 5 pods, and for that I'm going to use a kubectl scale command. If we switch to Kibana, then we'll be able to see that FileBit has already sent the logs from all the pods that are running in Kubernetes. And if we search for Autodiscover, then we'll be able to see that FileBit detected the new pods running Nginx image and has started an Nginx module to get the logs directly from the Docker container. This means that the Nginx logs are already parsed. Similar, we can collect the metrics from the Nginx service using the Nginx module in MetricBit. And then we can have a dashboard like this one that includes information collected from logs and metrics. Thanks for watching.
Okay, so in this presentation, what you have seen is that I used the Kibana visualizations, generic ones, to visualize Kubernetes infrastructure. So I think it makes sense for Kubernetes infrastructure to have more specific visualizations. And I mentioned this at the beginning, that I think it makes sense to offer a high-level overview of your Kubernetes infrastructure. So recently we are working on this map that we are calling the waffle map, because it looks like a waffle, where each of this a square is a pod, and you can group it by namespace, pod name, container name, and so on. Basically, you can group it by any field that exists in the event that is created by the bit. You can also filter by, for example, if you want to filter for all the pods that have a specific namespace. And what's also important is that the color of this of each square is determined by a metric. So here is CPU usage, the metric, but it can be anything, any metric that is part of the event, events that are generated by the bits. So this is looks like in the real world, right? But usually you will have like squares like orange or green or a red, depending on the color or on the value of the CPU usage in this case. So I would like to show you a small video of how this works. So basically, as you can see here, this is the waffle map. And if you click on one of the waffle of a square, you can see more details about that particular pod. So you can see not only metrics, but also you can see the logs that are coming from that particular pod. Oh, sorry, here it was hosts. Now we are going to Kubernetes, and here you'll be able to group by. For example, it was namespace group by and group by container name. And also you are able to filter by the container name. And if we filter for file bit, then we'll be able to see all the pods that are part of this file bit. And here, as you can see, we can see metrics, but also logs. I think that's it. Now, if you have any questions, thanks for listening.
Thank you, Monica. Any questions?
Do you have some sort of multi-tenancy support for people with different privileges?
This is something that we are working on this on the Kibana side. But so what you've seen, I forgot to mention the most important thing is that the waffle map that you saw is just a prototype, so we didn't release it yet, right? But we are working on it. So of course it doesn't have advanced features for now.
Some questions left? So maybe one question. You show us that you can run the file bit also at a Docker within Kubernetes. So is it advised to run the monitoring file bit in the same pod or Kubernetes deployment?
So you will have a file bit and a metric bit for each node. That is monitoring all the pods that are in that node.
A question there is in terms of, so what you showed is very specific to how the Docker daemon logs its container logs. So do you know how it actually is going to change once they move to CRI-O or something like that as a runtime for Kubernetes?
That's a good question. Unfortunately, I don't have an answer here.
That's all right.
Okay, then. Thank you, Monica.
Yeah, thank you very much. And if you have more questions, yeah, feel free to come to ask me in private.